Calculation of direct runoff from the storm hydrograph. First we know what is storm hydrograph. Storm hydrograph is also nothing but hydrograph. It represents the total ordinates, the total discharge ordinates and versus time in the horizontal axis. Right, first of all, find the ordinates of storm hydrograph representing the total discharge Q at a given time interval, say T. So once we know the storm hydrograph, then we are going to determine the direct runoff ordinates. We know what are the direct runoff ordinates. So direct runoff is the combination of surface and subsurface runoff, and remaining ground flow is the separate. So first of all, we are going to separate the ground flow from the above two flows, that is the interflow as well as surface flow. Right here, once prepare the storm hydrograph, then we are going to separate the base flow from the direct runoff ordinates. Once we are going to separate the base flow from the direct runoff ordinates, then estimate the direct runoff ordinates, that direct runoff ordinates equal to storm hydrograph ordinates, that means total hydrograph ordinates minus base flow, you have the direct runoff ordinates. Right, this direct runoff ordinates gives the discharge only, not depth, that are in units meter cube per second. Then that discharge ordinates can be diverted, they can be converted into direct runoff depth. We are going to estimate the direct runoff depth. For the determination of direct runoff depth, we have one formula, that is 0.36 sum of direct runoff ordinates into time interval, that is depends upon the requirement, and catchment area, that is square kilometers, catchment area in square kilometers. Then by using this formula, we are going to determine the direct runoff depth. So this is one problem, for example problem here. So these are the rainfall durations. These are not rainfall durations, these are the flood durations. Here, before going to determine the direct runoff depth, you should know what is rainfall duration, what is storm duration, what is effective duration. Already I told you the difference between effective duration and rainfall duration. Effective duration is the duration the rainfall intensity is more than the infiltration capacity of the soil. Here you should know the difference between storm duration as well as rainfall duration. Rainfall duration is different from storm duration. If, for example, if in a particular area, the storm falling on a particular area, the storm duration is 3 hours. The flood duration is not 3 hours, should be more than, because having some flow on that particular area. Therefore, these are the storm duration. These are the storm duration, that is date 14/8/65 and 5 hour, 8 hour. That means the interval, time interval is 3 hours, 5 hour, 8 hour, 11th hour, 14th, 17th, 20 and 23. The time interval is 3 hours time interval. Corresponding ordinates of hydrograph. These are the total hydrograph ordinates or storm hydrograph ordinates, that are at 5th hour 14 meter cube per second, 8th hour 25 meter cube per second, 11th hour 51 meter cube per second, 14th hour 65 meter cube per second. This is the peak discharge. This is the peak discharge. Again gradually decreases the discharge. These are the storm hydrograph ordinates. We want to determine the direct runoff depth. For the direct runoff depth, we should know the direct runoff ordinates. So already I told you direct runoff ordinates equal to storm hydrograph ordinates minus base flow. Base flow also here they have given. These are the base flow values. We want to determine the direct runoff ordinates first, then go to direct runoff depth. Direct runoff ordinates equal to ordinates of storm hydrograph minus base flow. 14 minus 14 equal to 0. Then ordinates of direct runoff, ordinates of storm hydrograph ordinates 25 and base flow is equal to 12. This is 13. Like that, these are the ordinates of direct runoff. Once we calculate the direct runoff ordinates, then go to use this formula and calculate the direct runoff depth. Here the sum of the ordinates of direct runoff equal to, that are 166. Then 0.36, this is the formula. Here sum of the direct runoff ordinates 166 into time interval is 3 hours. This should be constant. The time interval should be constant for the entire span. That is also very very important. Here time interval is 3 hours and catchment area is 30 square kilometers. Then finally we have the direct runoff depth equal to 5.98 centimeters. So this is the way to calculate the direct runoff depth. So direct runoff depth should be expressed in centimeters. Now we are entering into the unit hydrograph. So what is unit hydrograph? Unit hydrograph is the hydrograph as like hydrograph, but it represents 1 centimeter runoff at a unit duration of specified areal distribution. Unit duration of specified areal distribution. Unit duration means that is the rainfall duration, that is the effective rainfall duration. At a specified areal distribution means the rainfall that is specified, that unit duration should be falling on a particular located area for a given located area, then only this is possible. Right? Once again, unit hydrograph is also hydrograph. It represents 1 centimeter runoff depth or direct runoff depth at a unit duration and specified areal distribution. Right here, for example, one catchment area, that is Nagavali catchment area, having some rainfall, that is intensive rainfall of duration 3 hours. Right, we are going to prepare the unit hydrograph for that intensive rainfall 3 hours. Out of 3 hours intensive rainfall, the effective duration should be less than the 3 hours. Okay, so we should take the effective rainfall. So instead of 3 hours, so 1 hour rainfall quantity directly infiltrates into the ground. We are having only 2 hours rainfall is the effective rainfall. Then we are going to prepare the unit hydrograph. The effective rainfall is 2 hours. 2 hours of effective rainfall indicates that 2 hours unit hydrograph. Right, like that. Here, that is the that means that is the unit duration, and specified areal distribution means the rainfall should be falling on the catchment of Vamsdhara or Nagavali catchment only. If we are going to take the Nagavali river, then the catchment should be considered Nagavali river. Then we are going to take the Vamsdhara river. Here also we are going to take the catchment only concerned to that Vamsdhara river. Right. The unit duration may be varies because, but that is depends upon the catchment area. Of the large catchment areas, generally the unit duration may be taken as days. The few hours in case of small catchments, but this is variable one. For the calculation point of view, the unit duration may be taken as with respect to basin lag. So already I told you what is basin lag. Basin lag is the duration between the centroid of the effective rainfall to the peak of the hydrograph. So this is the effect. This is the basin lag. Then we are going to take the unit duration is that 1/4 of the basin lag. Generally, if they have not given for your problem, then you are going to take that the unit duration is 1/4 of the basin lag. This is about unit duration. Then go to assumptions of unit hydrograph. Here, before going to apply this unit hydrograph technique in a real problem, in real practical problem, we should understand what are the assumptions used in the unit hydrograph. That are the first one, the effective rainfall is distributed throughout the whole area of the drainage basin. Throughout the whole area of the drainage basin. That means, for example, right, the first assumption is the effective rainfall is uniformly distributed within its duration of the specified period of time. Here, the intensity of rainfall varies from place to place. For example, the Srikakulam district is one catchment area. Here, if the rainfall intensity at Srikakulam is 5 mm per hour, but whereas Rajam is also part of the Srikakulam district, the intensity of rainfall in Rajam is 1 mm per hour. But that means the intensity varies from place to place. But our assumption is that the intensity of rainfall should be same for a given period, for a specific period. then that unit hydrograph theory should be valid. This is first assumption. Second assumption, effective rainfall is uniformly distributed throughout the entire area. So earlier case, that given duration the rainfall intensity is distributed uniformly. Now the entire area, for example entire Srikakulam district, the rainfall should be distributed uniform. That is also not possible. If in case Srikakulam having 5 centimeters rainfall depth, nearer to Srikakulam, Palakonda, there is no rainfall. This is nearer to Palakonda, Rajam, here having 1 centimeter rainfall. But that means the rainfall is varies from different locations. 5 mm, that is 5 centimeters, there is no rainfall, here 1 mm. So the rainfall varies different places. But our assumption is that the rainfall is distributed, uniform distributed entire catchment area. That is the second assumption. And next one is the base or time duration of the hydrograph of direct runoff should be constant for entire span. Already I told you one problem there, the spacing equal to 3 hours. That is the baseline, that is the base or duration of the storm. That should be followed with a constant intervals, with a uniform intervals. That is the another assumption. And this unit hydrograph, this hydrograph or runoff is also depends upon the combination of physical characteristics of the basin. This is also affects the unit hydrograph theory. These are the assumptions used in the unit hydrograph. Then construction of unit hydrograph. I told you unit hydrograph is also hydrograph, but it represents 1 centimeter rainfall depth. Right here, once you see the diagram, this is the flood hydrograph. This is the flood hydrograph. So suppose here this is the baseline. This is the baseline. So below the baseline, that is the groundwater flow. Just above the baseline, this is the direct runoff hydrograph, simply known as direct runoff hydrograph or runoff hydrograph, right? Or flood hydrograph, right? Unit hydrograph means it represents 1 centimeter runoff depth. 1 centimeter runoff depth means already we solved one problem there earlier. The direct runoff depth equal to 5.9 centimeters. Instead of 5.9 centimeters, unit hydrograph represents only 1 centimeters. For example, this hydrograph, this flood hydrograph is for 5.9 centimeters. Then, with respect to unit hydrograph, for 1 centimeter rainfall, this is the hydrograph. This is nothing but unit hydrograph because this represents only 1 centimeter rainfall depth. This hydrograph represents 5.9 centimeter runoff depth. This is 1 centimeter runoff depth or direct runoff depth. Is it clear? Next. Here, for the construction of unit hydrograph, we should collect the data from the offices. First, from the first record, select some unit period of intensive rainfall during duration corresponding to an isolated storm uniform distributed over the area. Yes, this is also very, very important. Before constructing the unit hydrograph, we should select from the unit hydrograph theory, the construction of unit hydrograph, from the first records, select some unit period of intensive rainfall duration corresponding to an isolated uniformly distributed. Because here intensive rainfall is important. If catchments, different catchments having different intensities of rainfalls. But for the analysis, we are going to take the intensive rainfall duration corresponding to an isolated storm and uniformly distributed over the entire area. First of all, we are going to select that type of rainfall. Once we are going to select the intensive rainfall, then from the first records of the river, for example, we are going to select the Nagavali river, or we are going to select the Vamsdara river. Based on the intensive rainfall, we are going to collect the data of that intensive rainfall and prepare the storm hydrograph. Here, for the construction of unit hydrograph, also we should know the direct runoff ordinates. Because here direct runoff ordinates, what is the necessity of direct runoff ordinates? Unit hydrograph is also hydrograph but representing 1 centimeter runoff depth. That's why for the construction of unit hydrograph we should know, we should need whatever items are needed for the construction or determination of the direct runoff depth. Therefore, once after selecting the intensive rainfall on a particular area by collecting the data from that river, you prepare the plot the storm hydrograph. Once we are going to prepare the storm hydrograph, then go to as usual earlier procedure, separate the base flow. Once separate the base flow, then you know the direct runoff ordinates, below is the groundwater flow. Once we got the direct runoff ordinates, yes, that ordinates can be modified into direct runoff depth. Already I told you one formula for the determination of direct runoff depth. So direct runoff ordinates, subtract the ordinates of base flow from the total discharge ordinates, then we have the direct runoff ordinates. Right here, already we solved one problem here just now. So this is the formula for the determination of direct runoff ordinates. Why we are going to estimate these direct runoff depth, and also why we are going to determine the direct runoff ordinates? These are the used. These are necessary for the construction of unit hydrograph. So now go to unit hydrograph. Then we are going to determine the unit hydrograph. Unit hydrograph ordinates equal to, we know the direct runoff ordinates based on this procedure. Direct runoff ordinates divided by direct runoff depth. That means we have 1 centimeter direct runoff depth ordinates. Right? Finally, the unit hydrograph ordinates equal to direct runoff ordinates divided by direct runoff depth. Right? Now we are going to solve one problem here. That is, so this is another problem. Here they have given catchment area is 25 square kilometers, and these are the values. Once you see the board here, this is the date of rainfall, August 12th, 13th, 2 days continuously falling, and third day there is no third day rainfall. Here having 2 days rainfall, August 12th and August 13th, corresponding dates. These are the flood, not rainfall durations, flood timings. So this is very important. Here 6th hour, 8th hour, 10th hour, 12th, 14th, 16th. Like that, what is the span, what is the time interval between two successive 6 hour, 8 hour, 2 hours, 8 hour, 10 hour, 2 hours. So here time interval is equal to 2 hour. Corresponding 2 hour time gap, 2 hour time interval. These are the total ordinate discharges. You know the total, what are the total ordinate discharges. So total ordinate discharges, and also they have given base flow. Right? You know how to separate the base flow from the total ordinates, that already discussed just now. Then we are going to determine the direct runoff ordinates. For the calculation of unit hydrograph ordinates, we should know the direct runoff ordinates. Therefore here, so how to calculate the direct runoff ordinates? Just we have done solved one problem there. Like that, a storm hydrograph ordinates minus base flow equal to 1. Here also 8 minus 6 equal to 2. Here total ordinates, that storm hydrograph ordinates 10 and base flow is equal to 5.5. This 4.5 is the direct runoff ordinate. Direct here calculated total ordinates. Here peak discharge in this entire storm equal to 110 meter cube per second, and corresponding base flow is 2.50, and corresponding direct runoff ordinates is equal to 107.5. Like that, these are the ordinates of direct runoff. So once we calculate the direct runoff ordinates, that can be converted into depth. Depth means we have one formula here, that is this is the determination of direct runoff depth. Once we know the direct runoff depth, then only we are going to construct the unit hydrograph ordinates. Here this is the formula 0.36, this is the 822 is the sum of the direct runoff ordinates, into 2 is the time interval 2 hours. divided by area, that is given 25 square kilometers. Finally we have here 23.7 centimeters. 23.7 centimeters is the direct runoff depth. Once we know the direct runoff depth, then go to construct that means unit hydrograph. Unit hydrograph is also hydrograph, I told you once again, because this is very important topic, and also just little bit complicated topic also, right? So that here this is 23.7 centimeters is the depth of direct runoff. Unit hydrograph means 1 centimeter hydrograph. So for example, go to here, these are the ordinates of unit hydrograph. This should be ordinates of unit hydrograph should be less than the ordinates of direct runoff. Say the direct runoff depth is equal to 23 centimeters. These ordinates are related to 23 centimeters direct runoff. Unit hydrograph means 1 centimeter direct runoff ordinates is nothing but unit hydrograph. Here this ordinates of direct runoff ordinates divided by direct runoff depth 23 have 0, 2 by 23 have this value, 4.5 by 23 this value, like that. These are the values calculated. Here peak discharge is equal to 110, peak direct runoff ordinates is equal to 107.5. Here for 1 centimeter depth of runoff, the ordinate of this is equal to 4.5. These are the ordinates of unit hydrograph. For example, I show you earlier diagram here. This is the diagram. So this is the unit hydrograph diagram, because the ordinates are less for 1 centimeter direct runoff depth. This is the hydrograph. This is for 23 centimeters runoff depth. Right? Both are the hydrographs, but direct runoff ordinates are more than the strong unit hydrograph ordinates. Unit hydrograph ordinates means for giving 1 centimeter depth of direct runoff, then that hydrograph is nothing but unit hydrograph. Right? This is about unit hydrograph theory and unit hydrograph construction.